Hello all, welcome to the subject of VLSI Design and Technology. This is Professor Meenakshi Pancha from Electronics and Telecommunication Department, Parvatibai, Ganma Mulya College of Engineering. So, today's in previous lecture we have discussed about the multiple operators of VHDL coding. What are the operators and what command should be write for using that operators? We have seen in the previous lecture. For example, we have seen arithmetic operator, logical operators, shift operators we have seen in the last lecture. Today, in this lecture, we will see what are the data types used in the VHDL. Since HDL is implemented to describe the hardware of the system, the data or operands used in the language must have several types to match the end of the describing the hardware. For example, if we are describing a signal, we need to specify its type. So, such type is a bit or which means the signal can assume only 0 or 1 or type STD logic in which the signal can assume 8 values that include zeros and 1 and high impedance. For example, the type includes integer, real, vector, bit, array, etc. The HDL, especially VHDL, has an extensive set of the types. Many operations will not be executed if we do not specify the type required for the operations. The data type for the VHDL are discussed in today's lecture. The data types are implemented in almost when implemented or writing the code, we have to mention the data types. So what are the VHDL data types are? As previously mentioned or previously as I said, VHDL is a type-oriented language. Many operations will not be executed if we do not choose the right type of the operands. The type of any element or object in the VHDL determines the followed value that element can assume object in VHDL can be assigned. The variable, constant, such like that. These objects can assume different types. We can classify these types into 5 groups. Depending upon the nature of the value, the object can be assumed scalar, composite, access file, and other. In this slide, we will see scalar type and composite type, except that there are access file and other types also, data types also available. We will see in the next slide. So what are the scalar type means? Scalar types, the value that a scalar object type can be assumed are numerical. The numeric value can be integer, real, physical, characters when stored as a ASCII or compatible code or boolean. So such types are called as a scalar types. Let's see one by one. First see bit type. What is the bit type? The only value allowed here 0 or 1. So these are a bits and which is almost primitive type, which is used to describe the signal that takes only 1 that means high or 0 that means low. The signal cannot take other such values as a high impedance. Example implementing this type of when we describe the type of signal such like that we will see here. Quote Here, this is the one of the example implementing the bit type of port signals. Here, I1 and I2 are two input ports here mentioned in and which is type of bit. And 0, 1 and 0, 2, these are output ports which is mentioned by using out, and these also bit type. So this bit here, the input and output port which operates only bit type of signals. Input is also bit, it may be a high or low or 0 or 1, and output is also in the form of bit only. Here the signal I1, I2, 0, 1, 0, 2 can assume only 0 or 1. If any of these signal must assume other level or values such as high impedance. The bit type cannot be used. Such high impedance bit which cannot be used in this data type. Second one is a Boolean type. This type has two values, that is false and true, which is having two values, false or true. Both true and false are predefined word, and one of the most frequent application of the Boolean type is in the if statement. How we using this Boolean type data? By using if statement. If y that's equal to b, then then yes equal to 1. So such type of command. Here also another condition else. Yes equal to 0, semicolon, and if. Here in this example, here if is used in a Boolean type of, and here only two values will be operates on false or true. Here the output first time if y equals to b is Boolean, that is an either true or false. If true, if this condition is true, the yes will be going to store high. If this condition is false, then the yes is going to store 0. And after that we have to finish this if by using AND command and if. And how we are going to define port. Similarly, we are going to define port like this only. I1, comma, I2 in bit out bit will be 0 to y equal to b. This is a condition. Then what will happen if this condition is satisfied? Here the s is going to stored by the value 1. Else, if that condition is not satisfied, s is going to store the value 0. And we have to end the if statement here. This is the if statement here, which is used a boolean value, and the output of first line here, output of first line, how we will get port, how we write port organization here. Here I1 and I2 are two input. So in bit we have to mention like this, in bit, and output are 0 1. 0 1 are output and 0 2, which is a boolean. Here we are going to mention the boolean here. So this is a boolean type data type we are going to mention here. If with a boolean data type, some if condition will be used. If y equal to b, the values stored in y and b is they are equal, then this condition is going to satisfy. So if this condition is going to satisfy, the s is going to store 1, or the condition is not satisfied, so else s is going to store by 0. So these are true or false. True or false, such type of operation will be undergoes here. So how the port will be organized here? I1, I2 are two in bit. So here bit type of data will be flowing I1 and I2 terminal, input terminal, and output 0, 1 and 0, 2. There are two output terminals. 0, 1 will be get a bit only, but 0, 2 we are getting boolean. Boolean is true and false. So this is one of the examples of boolean type of the data. So next we will see integer type. So how we are going to write the integer type of the data. As the name indicates, this type cover all the integer values, can be negative or positive. All negative and positive values. All the negative and positive values are covered. And the default range here, the default range is, from -2147, comma 4848 to plus the same value. I'm going to copy the same value. So this is the default value. What are the value? Default value covered from minus this range to plus this range. This value, the integer value will be carried, and the user can specify a shorter range by using the predefined word range. The predefined word is natural and can be used instead of integer if the value of the object are always positive. So including 0. For example, of the integer type is implement of exponent operator. The exponent has to be of type of the integer, such as the exponent, or also type of the integer exponent, such as x is a value and double star. Here exponent in the HDL we will mention double star 2. So the value x square, here it looks like a x square, it's exponent of 2. or y or x. Both the variable value we can assign here. So y, these are also undergoes or comes in an integer form only. And the port can also be declared as the type of the integer. How the port can be declared for such integer? So we will have to write port I1 in natural. Sorry. Here I1 natural, that means integer value. And I2 full in bit. Here other is a in bit form input. And what are the outputs here? 0, 1 is one of the output. I am going to declare out and which is type of integer. Integer or 0, 2, which is Boolean. This is one of the example how the integer and Boolean value we can declare in a code. Here another predefined type of positive restricts the value object can take to be positive, which can be higher than the 0. So these are some examples of integer type, and let's see some examples of real type. This real type accept the fractions such as which accept the fractions value. Let's see how the real type will be operate. So real type, some of the fractions value like a port. So I1 in natural, I2 is in a bit form or example of real. So we have to write real. So these are 2-bit, and how the output will be out integer and 0 to Boolean. This should be declared by the user or programmer how the model is going to operate and what are the output you want to prefer and in which type the output have to be observed. This is the user type, but if you want to observe the real type data in output or input, we have to mention like here I2 in the input port we have mentioned that in I2 terminal it should be real data. Real data it perform on real data. At the terminal input terminal I2 real data should be flow for the operation. So these are the some real type examples of the real type data examples. So let's see character type of the data. In this type include character that can be used to print a message using predefined command. So we have to print as messages. So predefine some of the command we have to print. So this type of the data, what we are going to print, that is a data, and that type of data is called as a character type of data. So how we are going to print data? By using report command. Report variable x is greater than y. I want to print variable x is this command. I want to print variable x is greater than y. These are the some character inputs. These are the character input. So we are going to print select. Notice that each character in above message is just a printed. No value is assigned to them. The report statement is very similar to the print statement in C language. So we can add some format to the character printed by the report. We can add some characters also into the report. For example, report notice here the character is above message just is a printed purpose. No value is assigned to that. The report statement is very similar. The print statement in a C language, how we are going to print the message, that is similar here report. And we can also add some formats to characters to print by the report. For example, where and is a concatenation operator here. The and here in this message, add is a concatenation operator. And CR is a predefined word. Here CR is a predefined word for carrying return. If we went to assign the numeric value to each character, the subtype and type can be used as the follow. We should use subtype and type character we are used in the follow. The subtype and type and array are the predefined words type in this. The above two statements declare the how the character data type will be declared by using and sign. Also the and here and is a concatenation. The and symbol is used for concatenation the message. So next see another type of the operator here. Data type physical type. This physical data type values that can be messaged in units such as a time and milliseconds, microseconds. Here we are assigning unit. So for example, time will be measured in a nanosecond, second, or current will be measured, or volt, millivolt, microvolt, such types of unit are assigning in this type of the data type. For example, we are going to measure delay. So we are going to measure delay. So I want to write here delay of ENV, and that is data type is time which is going to assign in a form 1 nanosecond. Here nanosecond is a unit. Here nanosecond is a unit. Here above here this statement states that the delay underscore env is a type of the time, which is one of the type of the time, and its initial value is 1 nanosecond, and that initial value is 1 nanosecond. The word time is a predefined word. Here time is a predefined word, and unit time are as follows. The smallest units fs, ps, ns, vs, ms. So these are the some of the units. So these are units followed for measuring the time. So in our application, in our program, what unit we are going to use, or what unit that answer or result should be visible. So that unit we have to mention that. So there are many data types comes in a scalar types. So another are user defined type. Still there are many more data types is there. User defined type. The user can be defined a type by using predefined word type, which is shown in the below example, like a type OP is add, multiply and divide, comma, none. Variable opcode here OP is a user defined type. The variable opcode is of type of OP, and hence it can take an initial value of add, multiply and divide or none. So these are the user defined type. User can be defined such like that. And other types are also there. For example, another one is what type? This is another type of the data type which comes in a scalar type. This type used with the assert statement. For example, some statements are used. An objective with a type of severity can take one or four values: note, warning, error, or failure. For example, these are the types which will take, and we are going to define that by using assert statement. One of the flag here, that name is flag full, and we are going to assign by using false. This is the value. Such type of and report. Here some condition that flag full which is false. If the flag full is not a false, the message will be printed here. The following message will be printed like that the stack is full, and that stack is full, and simulated is halted, and simulation will be halted. If that condition is not satisfied, then that severity will going to failure. So such types of data types which is comes in a scalar type, and we will see some of the data types which comes under in a composite types. Those are bit vector type, array type, and record here. So we will see one by one what is the bit vector type. The composite type is a collection of value here. Composite is, this means collection of value. There are three composite types and bit vector array and record. These are the types of the composite types, and an array is a collection of values of all belonging to a signal type, and a record is a collection of value with the same different type, same or the different type here. Array is a collection of value all belonging to a signal type, or a record is a collection of the value which is having same or different types. So let's see one by one what are the bit vector type. The bit vector type represents an array of the bit, each element of the array in a single bit. And the one of the example we will see here, the implementation of type of the bit vector, that is port I1, here port I1 which is in bit I2 in vector 5 down to 0, and sum is out bit. This is the one of the example. Here the port I2 is declared as a type bit vector. Here the input I2 is declared as a bit type vector. It has a 6 possible bits, which is having 6 bits, and which is having possible value I2 includes 0, 0, 0. For example, here the 5 bits, here which is having 6 bits, sorry, here which is having 6 bit means 0, 0, 0, 0, 0. And so which is having multiple combinations like this 6 bit. So such type of declaration will be undergoes in a bit vector types. And what are the array types here? What are the array types? Here this type declared by using predefined word array. For example, the statement declares a variable memory to be single dimensional array of the 8 element, and each element is an integer. For example, this is one of the example that declare the statement declare that the variable memory to be single dimensional array of the 8 elements, and each element is an integer. Here each element of this integer we will going to declare by using a array command. Another one is a record type. We will see record type. An object record is a composed of element of the same or different type. For example, record types shows in figure here, or I'm going to write here. Type forecast. Here going to record temperature, integer, which range from -100 to one of the example how the record operation will be undergoes and how the data will be going to store and type of the data how we are going to declare it. So this is a real time and bit and record. Here the variable temp is a type of the forecast and type of forecast includes here one of the variable temp which is a forecast. And what forecast include? The forecast include a record. The forecast include a record and in the record we can mention like this. Here record will contains a temperature which is in a form of integer which having in the range from -100 to +100. And there are day information also. The day information will be in a real form or it may be in real form and the condition it is in a bit form. And here end is a predefined word which is mentioned here to assigning the record here. The record process will be going to end here by executing this end command. This is the record type of the data, which is comes under the composite data types. Similarly, physical. Similarly, that scalar type and composite types, there are other types like access type, file type, and other types. So access type, here the values belonging to an access type or pointer to be objects of the other types. For example, type TTR whether is forecast. Here this access type which is belongs access type are the pointers to objects of the other types. For example, type PTR weather is a access forecast. The whatever the example we have seen in the record type, there are a type forecast I have explained. So that forecast is going to access by using the redefined command access, and which is type of the access type. Here PTR weather is a pointer to forecast. Here one is a pointer is there to objects the other types. And another one example is the file type. Here file type is one of the object of the type file can be read from and written to using built-in functions and procedure that are provided in the standard library. Some of these procedures are functions file underscore open and file open file and read line to read a line from the file, write line to write a line into the file, and file close to close the file. More details about the file type and operation can be performed. In such type file type operation, such type of command will be used. And other types, there are several other types provided by the external library. The IEEE library contains a package with the name of std underscore logic underscore 1164. The package contains an extremely important type, that is a std logic, std underscore logic. We have seen that the type bit is only two values, that is logic 0 and logic 1 is there. If we want to simulate a signal and that assume a value more than 2 level, such as high impedance, and we cannot use bit type, and the std logic can be used to declare a signal as high impedance. So these are the std logic types. So here the logic has 9 values including 1 and 0. The package std logic underscore 116 should not be attached to the VHDL model. There are 9 values of std underscore logic types shown here like a, I will write here what are the types. Except 0 and 1, there are a total 9 values will be there. Here capital U is defined as uninitiated. Uninitialized. Uninitialized. And capital X is for unknown purpose. Unknown. Here 0 is for low. 1 is for high. And capital Z is for high impedance. Capital W is for weak, unknown. Capital L is for weak, low. Capital H is for weak, high. And this is for don't know. Don't or don't care. So these are the some of the values. These logic values, including 0 and 1, in the package std underscore logic underscore 116 should be attached to the VHDL model. And there are total 9 values of std underscore logic types. So std logic underscore vector type is also there. So std underscore logic type vector which represents an array. Here the std underscore logic underscore vector type which represents an array. Each element of an array is single bit or type of std underscore logic. See the example here, port Port I1 is in bit and I2 is in std underscore logic underscore vector, and which is from 5 down to 0. Right? Sum, which is output, we are mentioning by using out bit type. So these are the std underscore logic underscore vector type. Here, this is a array. Here, 5 down to 0. There are a total 6 bit. And 5 down to 0, total array is going to mention. Another one is signed. The signed is a numeric type and it is declared in the external package numeric underscore std and represent signed integer data in the form of the array. The leftmost bit is the sign. The object of the type signed or represents in whose complement form. Consider this statement. This statement variable signed. This is the statement which declares the variable pro. It is of type of signed and has a 4 bits and its initial value is 1010. So this is the type of the signed data type. Another data type is unsigned. Here the type unsigned represents the unsigned integer data in the form of array of std underscore logic and it is a part of the package numeric underscore std. The following here one of the statement. So this following statement is the examples of unsigned. Similarly, variable q out unsigned, which is from 3 down to 0. Here the statement declares the variable q out and which is type of unsigned and it has a 4 bits and its initial value is 1010 or 10. So this is the unsigned data type. These are the some data types used in a VHDL. These are the some of the HDL data types. So this is enough for the day. So in next lecture, we will going to see the style and type of the descriptions. What are the types of description? For example, there are many types of descriptions. One is a behavioral description and a switch level description, structural description, data flow description, and mixed type description. So how description will be takes place? So we are going to see in the next lecture. Yes, thank you.